In this fast evolving, growing competitive world, performance is the sole key to success. As a student, we have to perform in terms of our studies and life outside our classroom. Teachers are expected to perform in terms of their teaching and research activities. At the same time, the performance of institution we are being part of are also evaluated in a timely manner and ranked accordingly. The high frequency data available these days can be extensively used for evaluating the performance of decision making units, and such performance parameters can be used for providing insights and feedbacks based on which you can identify our potential and direction for future improvement in our performance. Efficiency and productivity analysis are evolving as a key tool for measuring the performance of decision-making units, including agricultural sector, educational institutions, banking, and even engineering processes. These two tools are going to be the pillars of this course, Applied Production Analysis using MATLAB, which can be placed under the broader umbrella of performance evaluation of decision-making units. Hi, welcome to the course Applied Production Analysis using MATLAB. I am Vipin from the Department of Economic Sciences, Indian Institute of Science Education and Research, Bhopal. At ISER Bhopal, I get involved in teaching, research and student mentoring, particularly in the area of applied econometrics and production analysis. In this short video, I am going to give you a brief outline of the course Applied Production Analysis using MATLAB, which is being framed with 12 modules spread across 12 weeks. In the week 1, I will be introducing you overall framework of performance evaluation, particularly focusing on efficiency and productivity analysis. In week 2, we start our journey of empirical estimation of production function. We will be estimating Cobb-Douglas and Translow production function using real data with the help of MATLAB tools. In week 3, we strengthen our theoretical understanding of production function, technical efficiency, allocative efficiency, and overall economic performance. Week 4, we start our journey of efficiency analysis using parametric tools, particularly corrected Eulers, modified Eulers, and advanced tools of stochastic frontier analysis. Week 5, we take a deviation. Instead of assuming any functional form, we empirically estimate the production function using non-parametric tools like DEA, and we'll be seeing the early model, that is basically Chance-Cooper-Rhodes CCR model, followed by the BCC model, Banger-Chance-Cooper model, and in the session we'll be estimating efficiency of decision-making units using our own MATLAB code. Week 6, we see some extensions of DEA model in case of super efficiency estimation, sequential frontier model, and also we relax the convexity assumption and see the case of predisposability higher. Week 7, I will introduce you to a very emerging field of non-parametric DEA, that is basically the bootstrap DEA, particularly the Simar-Wilson 2007 algorithms. Week 8, we are going to estimate the performance of decision-making units from a productivity point of view, where we see the early models like Fisher's, Tonquist, and an introduction to the Malkis productivity index. In week 9, we see various decompositions of Malkis productivity index following FGLR, FGNZ, and Ray and Desley approach. Week 10, I'll familiarize you with the parametric and semi-parametric tools for measuring performance, where we'll be seeing the Levinson and Petrin and Ole and Peck's model in a detailed manner. Week 11 is going to be of interest for non-economic student with a passion for environmental studies or even engineering. There we'll be estimating energy efficiency or environmental efficiency Going beyond, we estimate even green total factor productivity by accounting the environmental impact of each production process using real-time data. Week 12 will summarize the entire course. Also, we see some real-life applications of the tools that familiarized in domains like agriculture, banking, finance, education, health, so and so. Moreover, we'll be seeing how to integrate the cutting-edge tools of AI and ML in the field of efficiency and productivity analysis. At the end of this course, you are expected to have strong theoretical understanding of the measures of performance. Also, this course can be considered first of its kind attempt to integrate MATLAB as an exclusive tool for evaluating efficiency and productivity. The tools that we are familiarizing can be applied in any area of your interest for measuring efficiency and productivity. Also, as a part of this course, we will be using real-life data set for experimenting with MATLAB. At the end of this course, you will be able to explore further opportunities in terms of research and learning in this field of efficiency and productivity analysis. Having said that, this course is going to be of interest to students and PhD scholars in the area of economics, management, and applied mathematics. Also, non-economic student, particularly engineering student who has a passion for data analysis, will also benefit from this course. I would like to thank NPTEL, Ministry of Education, Government of India for this opportunity, Center for Science and Society at IISER Bhopal for the technical support provided. Also, on behalf of the learners, I would like to thank MathWorks NPTEL support program team for the generous support in terms of providing access to MATLAB throughout the duration of this course, which will be going to be very helpful for the learners. I hope you enjoy this course. Hope to see you soon and enroll right now. Thank you.